Hello, grade 7s. This week we are going to be focused on probability and the different ways to express probability. This is found in section 7.4 in your textbook. As we go through these examples, you'll want to have a pencil and a paper and a calculator by your side. So first of all, let's talk about what probability is. Probability is just the likelihood that something will happen. So we're thinking about the chances that a certain event will take place. So we can often express this as a fraction. So we have the probability of a certain event. We can think about that as the number of favorable outcomes to that event out of the number of possible outcomes. Let's look at an example of this. If we consider a coin toss, what is the probability that the coin will land on tails? Well, let's think about a coin. How many tails are there on a coin? We know that one side is heads and one side is tails. So there is one tails on a coin, and there are two possible outcomes, heads or tails. We can think about the one option of tails being the favorable option, and then the other one, heads or tails, are the two possibilities. So we can write that or express it as the probability of tails being the number of favorable outcomes divided by the number of possible outcomes. So favorable outcomes, or tails, is 1. Possible outcomes, heads or tails, is 2. So our fraction would be 1 over 2, or 1/2. Now we can express probability in different ways, though. We can write it as a fraction, but we can also write it as a ratio, decimal, or percent. So if we think back to our coin example, we wrote it as a fraction, number of favorable divided by the number of possible. That gave us 1/2. But we could express it in other ways. So here we have an example. We can write it as a fraction, 1/2. Here's how a ratio would look. 1 to 2. We have this two little dots in between to make it into a ratio, and we think of that as a ratio of 1 to 2. If we think about this in decimal form, if you need to, you can go back to Unit 3 and review a little bit about how to convert between fractions, decimals, and percents. There are a couple ways to convert from a fraction to a decimal. We can multiply both our numerator and our denominator by the same number to make it into a friendlier number, or I can just divide my numerator by my denominator on my calculator to get a decimal. So the decimal in this case would be 0.5, and then our percent would be 50%. Remember that percent means per 100. So we have 50 per 100. Now probability, when we're thinking of probability, it can vary between 0 and 1. So if we're thinking of it just as a number or a decimal, it's going to vary between 0 and 1. A 0 probability means that the event will definitely not occur. It is something that is impossible. It has 0% chance of happening. On the other end, we have the probability of 1. That means the event will definitely occur. It is certain. It has 100% chance of happening. So if we think about that on a scale, here we have on one end 0, that is impossible. Then we go on and things become on a range all the way up to certain. So we have very unlikely up to very likely. Notice here in the middle we have an even chance. 50% or 0.5 is a 50-50 chance of something happening. Let's look at this in terms of a few different types of events. So if I use my scale here as a guide, let's think about what are the chances that all the rivers will dry up next week. Well, that seems like that's very unlikely. We would probably put that pretty close to 0%, probably not impossible, but very unlikely. A coin will land heads up when tossed. We already saw in that example that we only have two possibilities, and there's an even chance of either one. So we would say that there's a 50% probability that that will occur. How about you will eat some food today? Well, most likely you're going to eat some food. There is a possibility that some of you may be fasting or you won't get a chance to eat some food for some reason. But for most of you, it's very likely that you would. How about the sun will set tomorrow? I think we can say with absolute certainty that the sun will set tomorrow. So that would be 100% and a probability of 1. How about the possibility that a cat will give birth to a rhinoceros? Well, unless medical science and genetics has advanced far beyond what I thought possible, I would say that that is impossible. The chances of that is completely unlikely. So that would be labeled as impossible. How about it will snow in the Sahara? Well, we know the Sahara is a desert. It doesn't get much precipitation at all, and it's very hot, so snow is very unlikely. Probably not impossible, but very unlikely. How about the next baby will be born a boy? Well, we know there are two options. He'll either be a boy or she'll be a girl, so 50% chance. There's an even chance. What about it will rain in Calgary tomorrow? Interestingly, when we look at weather reports, often with chances or probability of precipitation, we'll see usually a percent. So if you look at the weather report, you'll see a certain percent chance of rain. And so we could look and see what our probability is that there will be rain tomorrow. Okay, we're going to take a look at another example. Let's say we have a bag that contains 100 Starburst candy. And in the bag we have 60 strawberry, 25 lemon, 10 cherry, and 5 orange. We can find the probability of pulling out a certain flavor, and we can write those as a fraction, a ratio, a decimal, and a percent. As we're going through these examples, have your paper and your pencil by your side, and you can pause it between each one so that you can follow along and see how you would write all these, and then we'll go through them together. All right, so the first one we're going to try is the probability of pulling out a strawberry. So go ahead and pause the video and think about this one. So if we look up here, we can see that we have 60 strawberries in the bag, so 60 possible favorable outcomes. We have 100 possible outcomes because there are 100 candies in the bag. And so our fraction would be our favorable outcomes over our possible outcomes, so 60 over 100. Our ratio is written in a similar way. We have 60 to 100 as our ratio. Our ratio of strawberry to all of them is 60 to 100. Now our decimal is pretty easy to write. If we have 100 on the bottom, we know that's hundredths, so we would just write it as 60 100ths or 0.60. Percent is also pretty simple. We have 60 per 100, so 60%. Okay, let's take a look at another one. How about the probability of pulling out a lemon? Go ahead and pause here for a minute and see if you can do that one. Okay, if we look at lemon, we can see that we have 25 lemon in the bag, so 25 favorable outcomes out of 100 possible outcomes. Our ratio would then, of course, be 25 to 100. Then our decimal, we can just write it as hundredths here. So we have 25 100ths, so 0.25. And again, we have 25 per 100 as our percent. Remember also, for percent, you can just move your decimal 2 places on your decimal form to get your percent form. We have 25%. All right, we'll look at another example. How about the probability of getting a lime? Go ahead and pause and think about that one for a minute. As we look at our possible flavors, we can see that lime is not one of the possible flavors. So we have 0 favorable outcomes out of the 100 favorable outcomes. Our ratio of lime to Starburst in the bag is 0 to 100. As a decimal, this would be our 0 probability. And there is a 0% chance that we will pull a lime out of the bag. How about the next one? A probability of pulling a Starburst out of the bag. Go ahead and think about that one for a minute. Well, of course, in our bag, we only have Starburst. So there are 100 favorable outcomes out of 100 possible outcomes. Okay, so I can write that as a ratio, 100 to 100. as a decimal, we could just write that as 1. 100 divided by 100 is 1, so that gives us our decimal. We would say it is 100% chance that we are going to pull a starburst out of the bag, since those are the only options that we have. All right, so let's think a bit about the difference between theoretical versus experimental probability. Theoretical probability is based on what we would expect to happen. All of the examples we looked at so far have been theoretical probability. What are the chances of something happening? What's the likelihood of something happening? Now we can also have experimental probability. That is based on an experiment. So let's look at an example of that. Here we have Max rolling a dice, 25, and he rolls it 25 times. And of course we have 6 different numbers on the dice, and so he kept a tally of how many times he rolled each one. And these are the results. Now, if we think about the probability of Max rolling a 5, according to his experiment, we can see that he rolled a 5 6 times out of the 25 times that he rolled. So that would be 24%. That is experimental probability because it's based on his experiment. Let's compare that, though, to the theoretical probability. If we just had our dice and we were just thinking about what the chances are or the likelihood of us rolling a 5, we would see that there is 1 favorable outcome out of 6 possible outcomes. So our theoretical probability would be 1 over 6, or we could write that as 16.7%. Okay, so let's think again about some experimental probabilities. What's the probability of rolling a 2? Well, in his experiment, he rolled a 2 3 out of the 25 times. So he had 3 favorable outcomes out of 25. An easy way to write this as a decimal or a percent is if I multiply this by 4. 25 times 4 is 100. So that makes it convenient. And then 3 times 4 is 12. So I get 12 100ths. That would give me 0.12 or 12%. Now as a ratio, I could write that as either 12 out of 100 or 3 out of 25. All right, how about another one? How about the probability of getting an even number? Now again, if we're basing it on experimental probability, we can look at the tallies here. We can see that for the even numbers, I had 3, 4, 5, 6, 7, 8. 8 out of the 25 times I rolled an even number. I can do the same thing here, multiply this by 4, I get 100. And then multiply the numerator, I get 32. So I have a 32% chance of rolling an even number according to my experimental probability, or 0.32. What about the probability of a number greater than 1? Well, Max rolled 1 4 times. I can just subtract 4 from 25 rather than adding them up. It's a little quicker. So I get 21 out of 25. If I multiply that by 4, again I get 21 times 4 is 84. So I get 84% chance of rolling a number greater than 1 or 0.84. Okay, so the theoretical probability of rolling a 4, though, is I have 1 favorable option out of 6 possible options. So again, my theoretical probability would just be 1 over 6, or 16.7%. Okay, so notice that the probability for rolling any number in my dice is the same in theoretical probability, even though it is different for experimental probability. So go ahead and take a look at your questions and see if you can do the workbook pages and textbook pages.